So this is day 3 of Trig Chapter 4 from the textbook. So real quick, we want to find, oh man. Real quick, what we want to find out is these angles. So this is yesterday's work, really. And we'll talk about the reciprocal ratios in a second. So let's say tan theta is equal to that number there. And I want to figure out what values, what angles of theta is that true for. Well, let's use our cast law. Okay, and I keep doing this. I'll keep going back and forth with this. I got this thing here, and I got this thing here, 180 minus theta, 180 plus theta, and then 360 minus theta. You'd be using these over and over again. So what I do here is tan theta is positive, tan theta is positive, so I know my answer is going to end up in quadrant 3 and quadrant 1. Everything is positive in quadrant 1, tan is positive in quadrant 3. I throw this in the calculator, I hit second function tan, I get the inverse tan of this to find out what theta is, and I get 19 degrees. Actually, oh man, messed it up. Okay, so the homework question is actually sine theta. Is that? So sine theta is positive in quadrant 1 and quadrant 2. I throw that in the calculator, sine inverse sine this, and I get theta is 19. My other answer is in quadrant 2. So how do I get to quadrant 2? To get to quadrant 2, I just go 180 subtract 19, and the other answer is 161. Throw that in the calculator just to check your work. If I go 161 sine, I'm going to get this answer here. Okay, so sorry about the mess up with the tan and the sine. Let's go to cos theta is equal to a negative answer. Well, what I want to look at here is where am I going to have negative coses? I have positive here and positive here, so I have negative here and negative here, so my answers are in quad 2 and quad 3. If you throw this into the calculator, you get a negative answer a lot of times. Sometimes you get a positive answer. I just like to ignore the negative. So what I do is I throw this into a calculator. I say, okay, hold on a second. Let's find out what if I had this, I'd have the related angle in the first quadrant. I know that's not what I want because I want a negative. I want it in the second and third quadrant. But let's figure out what the related angle in the first quadrant is. So I throw this into a calculator, and this question here is question E from your homework. And when I do that, I get theta is equal to 70 degrees. So that's in the first quadrant, which I thought it would be. So that's in the first quadrant. How do I get to the second quadrant? It's 180 subtract theta, or 180 subtract 70 is 110. And in the third quadrant, it's 180 plus theta over here. So 180 plus 70, and that's 250. So my answers are 110 and 250. Okay, the other type of question that I could have is one where I have exact answers. So I have something like tan of, so a little bit different here. Oops. Let's go with this. What is the value of tan of, so this is a little different, tan of 225. Okay, so this is a little bit different, but let's figure out where we are here. 225 is in quadrant 3. So I'm going to end up in the third quadrant here. So tan of 225 is, cast law says that, no, that's not right. I messed up my cast law. Cast law says that it's going to be positive. So what happens here is I'm going to figure out the related angle in the first quadrant and then keep it positive because it's according to cast law, tan 225 is positive. So what is the related angle? Well, I know that to get from the first quadrant to the third quadrant, I go 180 plus theta to get to the third quadrant. So I work backwards to figure out what theta is. So 180 plus theta is my answer, 225. That's the related angle in the third quadrant. I solve for theta, I bring the 180 over, and I have 45 degrees. So now I look at my table and I say tan theta, or tan 45 degrees for my table is equal to 1. And therefore, if that's 1, then in the third quadrant, that is also 1. I don't change the sign here. So tan 225 is related to tan 45. They're the same size, and cast law says that they are the same sign also. So my answer is 1 here. Okay, let's do another one where I have to change the sign. So no pun intended here. Let's do the last one. Sine 315. Sine 315 is in which quadrant? It is 1, 2, 3, 270. I'm in the fourth quadrant. In the fourth quadrant here, only cosine is positive, so therefore sine is negative. So that's that. When I'm all said and done, my answer better be negative. What's the related angle in the first quadrant? Well, I go 360 subtract theta is equal to 315. I'm in the fourth quadrant, so 360 subtract theta gets me a related angle in the fourth quadrant, which is 315. I work backwards, and I figure out that theta is, or I solve for theta, sorry. So I'll bring this over here and that over there, or whatever you have to do. And your answer is 45. Sine 45 is 45 is related to 315. Sine 45 for my table is 1 over root 2, which is fine, but I also know, according to the cast law, that in the fourth quadrant, sine is negative. So sine of 315 is equal to 1 over root 2, but let's make that whole thing negative. Okay, so that's the homework. And then we're going to move on from there to reciprocal ratios. And reciprocal ratios are based on they're flipped versions of our base ratios. So I have sine, and I have cos, and I have tan, and that's opposite over hypotenuse, and that's adjacent over hypotenuse, and that's OA, opposite over adjacent. But if I want to know what's the ratio called for H over O? So instead of the ratio of opposite to hypotenuse to opposite, we call this cosecant. And then we call secant the ratio of hypotenuse over adjacent, and then we call cotangent A over H, adjacent over hypotenuse, which is our reciprocal of tan. So another way to say this is that sine is cosecant is equal to 1 over sine, secant is 1 over cos, and tangent is 1 over cotangent. Sorry, is 1 over tan. I remember this way: C goes with S, S goes with C, and then cotangent and tangent go together. So if you're given questions like this, hey, real quick, what's from this angle here from A? Okay, so if I'm over here and I say, hey, what is the cotangent of A? Well, the cotangent of A is 1 over the tangent of A. So I can either figure out the tangent of A and flip it, or I can say, okay, that's H over A, and A being adjacent, hypotenuse over adjacent. So if this is my angle here, I should use theta, I guess, but if this is my angle here, this is hypotenuse, this is opposite, and this is adjacent. So hypotenuse over adjacent is then 5 over adjacent, which is 4, which is 5/4. So the cotangent of A is 5/4. And that's basically how that stuff works, okay? And everything else is the same there. Working backwards, though, we never, if you look under calculator, you probably do not have things for, like if I said, hey, what's the cosecant of A is 4, what's the value of A? You look under calculator, you can't hit second function cosecant. I don't know, I don't think your calculator will have that. And you don't need it, right? Because cosecant of A is 4. That would mean that the sine of A, I flip that over, is 1 over 4. Okay, so if cosecant is equal to the inverse of sine, then 1 over cosecant is 1 over 4, which is the sine of A. Throw that in a calculator, throw 1 over 4 into a calculator, hit second function sine, and you get 14 degrees. So the sine of 1/4 is, the sine of 14 degrees is 1/4. The cosecant of 14 degrees is 4. Okay, so it's a reciprocal there. So if let's move on to this one. Secant of B is 5/3. I'm not going to look that up. Secant goes with cosine, so cos of B is 3/5. Throw 3/5 or 0.6 into the calculator, hit second function cos to figure out that that is in fact 53 degrees. So B, sorry, I shouldn't do that. B is 53 degrees. B is 50 degrees here, it's 50 degrees here. So B, that's how you get that. Let's look at this. If I say, hey, where is secant root 2? Well, I'm not going to answer that question, really. What I want to answer is this. Secant is root 2 is the same as asking, where is cosine 1 over root 2? Okay, and that's the question from yesterday. So once you realize that these new questions aren't new, secant goes with cosine. Cos is 1 over root 2. Where is that? Well, it's positive, so it's in this quadrant, 1 and 4. I use my table to find out that cos theta is equal to 1 over root 2 when theta is equal to, I believe, 45, right? So if I go in my table, my chart tells me that theta is equal to 45 cos 45 is equal to 1 over root 2. Well, that's great. So where else is that true? Well, it's also true, that's in the first quadrant. How do I get my angle in the fourth quadrant? Well, I use this thing, this guy over here. I already wrote it once today. I think I did. Maybe not, yeah. This guy here. And how do I get to the fourth quadrant? It's 360 minus theta. So I'm going to go here and I'm going to say, that's great. So in Q4, I go 360 minus 45. And then that gets me 315. So my answers are 315 and 45. So really, I mean, there are tables. I gave you a table here of the special angles for cosecant, secant, and cotangent, but I wouldn't even bother with that, really. Like you look at other things like this. When is cosecant, that's not right, cosecant is that, of theta equal to -2 this, okay? I'm not going to answer that question. It sounds like I have something to hide by not answering that question. It sounds like I'm in court. Okay, but let's look at this. I just flip it, okay, and I leave it negative. When is sine theta root 3 over 2. Now, I've never been in court, by the way. Negative root 3 over 2. That question here, let's use Cast law. Positive, positive here, and negative, negative here. So my answers are here. What I'm going to do here is I look up at my table. Sine theta is equal to root 3 over 2 when theta is equal to 60. Okay, so my table tells me that. That's great, but I want quadrant 3 and quadrant 4 answers. So to get to quadrant 3 and quadrant 4, I go 180 plus theta, or 180 plus 60, 240. And here I go 360 minus 60, which is 300. So my angles are 240 and 300. That's how I would do that. Okay. I know there are other tables for that sort of thing, and that's great. If you want to use them, use them. Another question here, if we keep going, I could ask you a question like this. What are the trig ratios for 225? Okay, so here's the question. What are the 6 trig ratios of 225? Well, 225 is in this quadrant here. Okay, so I'm in quadrant 3. So let's figure out what the related angle in quadrant 1 is. So 180 plus theta gets me 225. So 180 plus theta is equal to 225. The angle in quadrant 1 that's related is 45 degrees. Okay, we figure that out. And then we just go through there and we say that we use our table, original table, sine theta, sine of 45, cos of 45, and tan of 45. And we have some negatives we're going to throw in here in a second. But let's look at this real quick. And that's 1 over root 2, 1 over root 2, and 1. Okay. And then if I want to find what cosecant of, oh, this would be 45, 45, 45, and 40. Oh, sorry, 225, 225, 225. Cosecant of 225, secant of 225, and cotangent of 225. And these aren't the right answers yet, so hold up. And I want to figure out what these guys are. Well, sine of 225 is 1 over root 2. Well, the cosecant is the reciprocal of that, or root 2 over 1, or just root 2. Same with this, that's root 2, and then flip 1 to get 1. Now, we do have to use Cast law, though, to figure out in the third quadrant what is positive and what is negative. And the only thing that's positive is tangent, so everything else is negative. So if this is negative and I flip it, if sine is negative and I flip it, so if I flip 1 over root 2, if I flip that, I get root 2 over 1, which is root 2, but the negative doesn't disappear. So if sine is negative, so is cosecant. If cosine is negative, so is secant. Tan is positive, you can put a plus there or just leave it, and so is cotangent. Okay, so the Cast law also works with the inverse ratios. We don't have a special one for it. Just know that sine goes with cosecant. So if one is positive, the other one is positive also. Besides that, there's not much else to do really, except when we have ratio. I mean, the only other thing would be a question like this: if secant of theta is -3, what is theta? I'm not going to answer this question, Your Honor. No, just kidding. I'm going to answer this question right here. 1. Okay, flip it. So root 3 becomes 1 over 3, -1 over 3, which is what I have there. That's a 3. And cos theta is that. Okay, so I know where does that take place. Cast law tells me that takes place in this quadrant, in quadrant 2 and quadrant 3. I'm not going to look this up in my calculator. What I'll do is I'll find the related angle in the first quadrant, which is going to be my positive theta. What's up with my 3's lately? I could make 5's, now I can't make 3's. So I throw that in a calculator. Second function, cos 1/3, and I get 109 degrees. I get 71 degrees. Okay, if you put -1/3, you'll get 109 degrees. Okay, and that's your answer in quadrant 3. But the truth is, I don't really want my answer in quadrant 3. I want my answer in quadrant 1, and then I'll move it to quadrant 3 and quadrant 4 anyway. If you get 109, what you're going to have to do anyway is move it to quadrant 1 and then move it to quadrant 3. Okay, so what I do is this. This is my answer in quadrant 1. To get to quadrant 2, it's 180 minus 71, which will give me 109, which is my answer. Okay, and if you said, well, I could have got it in the first place, the problem is, how do you get the quadrant 3 answer? You would have to go backwards and get 71 in the first after that, and then add it to 180. So 180 plus 71 is 251. And what I'm saying is these things, theta, 180 minus theta, 180 plus theta, and 360 minus theta, that's going from quadrant 1 to these quadrants. If I'm in quadrant 2 and I want to figure out how do I go to quadrant 3 with my related angle, you have to go back to 1 and then to 3 anyway. So what I do is I start in quadrant 1 and then I figure out where I want to go. So 109, 251 are, well, I'll have cosines of these angles is -1/3. And if that's the case, then it has a secant of -3. Okay, so that's how I'm going to do those questions. There's a bunch of calculator steps on the back of that. And then that